Today we will discuss projection. So actually by projection our intention is to obtain a two-dimensional figure from a three-dimensional object. So actually it's an image cast on a plane. There are different planes where projection is obtained. One is vertical plane, the other is horizontal plane, and then profile planes. Suppose we have an object like this. So if we look from the front, the image will be obtained on a wall. Maybe the wall behind me can be considered as a vertical wall, and the front view will be a rectangle. Now if we look from the top at an angle 90°, again the top will be a rectangle having this much length. Its thickness will be this much. And if we look from this side view will be a rectangle, and that length of the rectangle will be this much, and the width will be equal to the thickness. If we draw the front view of it, it may be like this. Now the top view projecting from the front view. Okay, if you look from the top, you will see this like this. Now if we look from the left side, you will get the side view on the right side of the front view in first angle projection. Again there you can see the thickness of the object. Okay, this is the front view, this is the side view, this is the top view. Front view is also called elevation, side view is called end view, and top view can be also called plan. If we sum up all these three views and obtain a multi-view projection, or and obtain a single view, so that will be a 3D picture. So that is called isometric view. So that will look like this. So if we look from this front, you will get this front view, and if we look from this side, you will get this side view, and if you look from the top, you will get this surface, that is this top view. In the figure we see a plane of projection. On the plane of projection we are getting the image, and from different points of the object different rays are falling on the plane of projection, so that we are getting the front view. These lines are called the lines over which arrows are put are called line of projection or simply projectors. Line of sight. The line joining different points of the projection and the eye of the observer is known as the line of sight or visual ray. See, the observer is assumed to be remaining at infinity. What we see is the front view, orthographic projection. A line of sight joins different points of the projection with the observer's eye. Observer is assumed to be situated at infinity. Classification of projection. Projection may be divided into parallel projection and convergent projection. And parallel projection is divided into orthographic projection and oblique projection. So we will concentrate on orthographic projection. Orthographic projection means the projectors are falling on the plane of projection at an angle 90 degree. Orthographic projection is again divided into multi-view projection and axonometric projection. Multi-view projection means can be divided into first angle projection and third angle projection. Second angle projection and fourth angle projection are not used. Axonometric projection means a single view projection which gives a clear idea regarding the object. That is isometric projection, diametric projection and trimetric projection. In the case of convergent projection or scenographic projection or perspective projection or center projection, simply we need to think that convergent projection means perspective projection. Perspective projection can be 1 point perspective, 2 point perspective or 3 point perspective. This is the overview of the projection. Mainly we have parallel projection and convergent projection. Under parallel projection, orthographic projection. Under orthographic we have multi-view and axonometric projection. Multi-view projection means the projection front view, top view, side view, etc. Axonometric projection means isometric projection. Convergent projection means perspective projection. When the point is in the first quadrant, say this is first quadrant, this is second quadrant, this is third quadrant and this is fourth quadrant. This is called an anti-clockwise system. Anti-clockwise system. So this is horizontal plane, this is vertical plane, and of course first quadrant is above HP. For a person looking from here, it is in front of VP. Similarly, second quadrant is above HP, behind VP for a person looking from this side. And this is third quadrant, below HP, behind VP for a person looking from this direction. Now this is below fourth quadrant, below HP, in front of VP. So this is how we designate 4 quadrants, and this horizontal plane can be rotated in the clockwise direction. So horizontal, this portion will come down and this portion of the horizontal plane will go up when we transfer the 3D objects, projection of 3D objects into a plane geometry or 2D surface. Now all these planes are transparent. For a person looking from this side can see any point here. For a person looking from the top, for obtaining the top view, if a person looks from top, he can see third quadrant as well as fourth quadrant. So today we will learn about quadrant system. So we have the entire space divided into 4 quadrants using 2 different planes at an angle 90 degree. The one is vertical plane, the other is horizontal plane. Horizontal plane can be extended to this direction and vertical plane can be extended to downward also. So this is first quadrant, second quadrant, then third quadrant and fourth quadrant. Now suppose a point is here 20 mm above HP and 30 mm in front of VP. The point name is capital A, 20 mm above HP, 30 mm in front of VP. The person is looking from this direction. So the front view will be obtained here, and top view will be obtained here. This distance it is 30, and this height is 20 mm. After having obtained the front view and top view, the top view has to be rotated. Top view is obtained in the horizontal plane, that has to be rotated. Vertical plane will not be rotated in the clockwise direction, so that we will get front view and top view in a single plane. And this is nothing but intersection of HP and VP. That would be a line, and that is called a XY line. So front view will be 20 mm above XY line and top view will be 30 mm below XY line. Now think that the point is in the first quadrant, 20 mm above HP and 30 mm in front of VP. The point is here, let it be capital A. A point can be designated using capital letter. Now let us obtain the front view. The person will be looking from this in this direction. So its projection will be obtained here on the vertical plane. This is the vertical plane. Now for obtaining the top view, we will be looking from the top, just above at an angle 90 degree, just above the point we will be looking, so that we will be getting its plan or top view on the horizontal plane. Now this horizontal plane has to be rotated in the clockwise direction, so that this point will be moving to here. So this is the top view. So that is, top view is always designated as using small letter A, and front view is designated as a small letter A with a prime, small with a with a dash. A dash is the front view and A is the top view. So if we draw separately, first we have to draw a line that is called XY line. It is nothing but the intersection of horizontal plane and vertical plane. Intersection of HP and BP is a line, and that is called XY line. And in this example, front view will be obtained 20 mm above XY line, and this is A dash, and we can dimension here, so that value beautifully you have to dimension. It is 20, and top view has to be 30 mm below, so that is small a, and that again has to be dimensioned. This is dimension line, termination. This is 30 dimension. This is projection line. This is the answer for the problem. Now we will discuss the case of second quadrant. So here the point is 20 mm above HP and 30 mm behind VP. The person is looking from this direction. So front view will be obtained here 20 mm above XY line, and top view will be obtained here. This distance will be 30 mm. After having obtained the top view, the horizontal plane will be rotated in the clockwise direction, so in this way, so that both front view and top view will lie in a single plane and both will be above XY line. This is the XY line. Suppose when a point is situated in the second quadrant, you know this is HP, this is VP, so this is second quadrant. Point is situated 20 mm above, 30 mm behind, so let the name of the point be capital B. This is 20 mm, this is 30 mm. Point capital B is 20 mm above HP and 30 mm behind VP. So the person is again looking from this direction. The front view will be captured here. What it has to be named? It has to be named B dash. Now top is here. If you look from the top, for obtaining the top you have to look from the top. So now this will be obtained here. So this B is the top view. But our rule is that after obtaining the top view on the horizontal plane, it has to be rotated in the clockwise direction. So portion behind VP, the portion of the horizontal plane behind VP has to be rotated upward so that it may reach here. So when we rotate it in the upward direction, this horizontal plane portion, when rotated upward, you will obtain the top view here. So if you redraw it in a neat way, so this is XY line as we saw earlier. This is the intersection of HP and VP, and front view will be obtained 20 mm above, that is B dash. Then again B will be obtained still further, so this is 20 and we have to dimension that one, that is 20. Now this is 30 mm. So front view and top view above XY line. Now this is the third quadrant. So point is 20 mm below HP, 30 mm behind VP. The person is looking from this side. So top view, front view will be obtained here on the VP, 20 mm below this intersection line XY line, and top view will be obtained here. So after having obtained the top view, the HP has to be rotated in the clockwise direction so that the top view will be above XY line and front view will be 20 mm below XY line. Moreover, these planes are transparent and having zero thickness, so any point situated in any quadrant can be viewed from anywhere. Suppose now the point is in the third quadrant, that is 20 mm below HP, this is HP, and 30 mm behind VP, because the person will be always looking from this direction. So of course, as usual, front view will be always obtained on the vertical plane, so it will be captured here, so that is C dash. Now of course top view will be captured on the horizontal plane and the person is looking from here. Top view will be obtained here, so that is small c, the top view. As our rule is horizontal plane has to be rotated upward clockwise direction, so naturally this will go here. So this is C. If we draw it separately, this is the X Y line, and 20 mm below you get C dash, and that may be dimensioned here. And now 30 mm above you get the top view C, small c, then you have to dimension that one also, so that is 30. This is the front view and top view of the point situated in the third quadrant. Front view is below XY line, top view is above XY line, because the point becomes behind VP. This is the fourth quadrant. Now the point is situated here. It is 20 mm below HP and 30 mm in front. Person is looking from this direction, and now top front view will be obtained here, 20 mm below this HP. It will be obtained here. Top view will be obtained here, and after having obtained the top view, the horizontal plane will be rotated, so that the front and top view will be in a single plane. That will both will be below XY line. This is the XY line intersection of HP and VP. In fourth quadrant system, front view and top view will be below XY line. Now the point is in the fourth quadrant, so that is 20 mm below at 30 mm in front of VP. The person is looking from here, and of course the front view is obtained at the vertical plane, that is D dash, and top view will be obtained here, that is on HP, that is small d. Now when we rotate in the clockwise direction, this top view will be going here, so we get D. Now if you draw it separately, this is XY line, a horizontal line, 20 mm below you will get D dash, then 30 mm below you will get D. Separately you can dimension this one. This is 20 mm, this is 30 mm. So this is the complete solution. Both the top view and front view fall below XY line. Now if we examine all the four previous problems, now let us check where the point was with respect to HP. In the first problem, the point A, capital A, was 20 mm above HP. In the second problem also, the point capital B was 20 mm above HP. Now in the third and fourth problem, the point was 20 mm below HP. Now if we look at the solutions, we clearly see that whenever the point was above HP, its front view was above XY line, and whenever the point was below HP, its projection was below XY line. So in short, we can say that if the point is above HP, front view will be above XY line. If the point is below HP, front view will be below XY line, depending upon the how much above and how much below. If it is 20 mm above HP, it will be 20 mm above XY line. If it is 20 mm below HP, it will be 20 mm below XY. In short, we can say that to draw the front view, if the point is above HP, front view will be above XY line. If the point is below HP, front view will be below XY line. So to draw the front view, we need to know the distance of the point with respect to HP only. To draw the front view, we need to know the distance of the point with respect to HP only. Now, what about the top view? If you analyze first 4 problems, in the first and fourth quadrant, the point was in front of VP. The first quadrant, the point is 30 mm in front of VP. In the fourth quadrant also, the point is 30 mm in front of VP. So if the point is in front of VP, top view will be below XY line. In the second and third quadrant, point is behind VP, so that top view will be above XY line. This is because in front portion of the HP, only we are rotating the HP. In front portion of the HP is rotated in the clockwise direction, and behind, so it will be coming down, and behind portion of the HP will be going up, and XY line is nothing but the intersection of HP and VP. So the portion going up will be above XY line in the projection. And in the first and fourth quadrant, since the front portion of the whole HP, in front portion of the HP goes below XY line, its top view will be below XY line. So in the first and fourth quadrant, top view will be obtained in the top view will be obtained below XY line. Second and third quadrant, top view will be obtained above XY line. Now if we consider another question, that is question number 5. Point capital E is on HP and 30 mm in front. So according to our principle, if it is on HP, if it is above HP, projection front view will be above XY line. If it is below HP, projection front view will be below XY line. So what will be the, where will be the projection front view if the point is on HP? Projection will be on XY line. So since the point is E, this is E dash. Now the point is 30 mm in front of VP. So this is in front of VP. Now in front portion will always come down. So 30 mm below we can mark E. So we have to dimension this one. If you know the actual situation, this is the VP, this is HP, the point is here, capital E. Front view will be obtained here, that is intersection of HP and VP, and it will come down. So this is E. This is the situation. Now question number 6. Point capital F is on VP 20 mm above HP. Draw the XY line. On VP means top view will be on XY line, F, small f. Now this 20 mm above means front view 20 mm above, that is F dash. So we have to dimension. So this is the solution. Question number 7. Point G is on HP 30 mm behind. So in this case, just draw the XY line. On HP means G dash on XY line. Then what about the top view small g? It is 30 mm behind portion when rotated will go up, so that here you will obtain top view of the capital G. We have to give the dimension, that is 30 mm. Question number 8. Point capital H is on VP 20 mm below HP. Draw the XY line, and now it is on HP means H dash is, sorry, it is on VP, not H dash. This is wrong. So this is H. Top view is on XY line. The point is 20 mm below HP. So 20 mm below you can mark H dash. Now your dimension 20 mm. Question number 9. Point capital I is on both HP and VP. So here both I dash and I will be I dash comma I dash comma I, both will be on XY line. These are the different ways a point can be situated, and indirectly also they can ask problems can be asked. That is, in all the previous problems, distance of the point with respect to HP and VP were given. If that is known, directly we can draw the front view and top view. If that is not given, but some clues will be given in the problem, so that we may have to find the distance of the point with respect to HP and VP, and after finding out that distance, we can clearly draw the front and top views. So with this we conclude projection of points. So next we will be dealing with the projection of lines.